Hey everybody. So today I want to talk about how we can make better subpatchers and abstractions. And this is a video I've been wanting to make for a while now because I've been figuring out for myself just best practices around how to build smaller patches that go within patches in Max so that my patches are easier for me to understand in the future, easier for other people to understand, and easier to reuse. So I've figured some stuff out along those lines and I want to share them with you. I don't think this is complete by any means and I would love to hear your feedback, but I think that by following some of the principles that I talk about in this video, you'll be able to make patches that are easier to build, easier to maintain, and easier to understand in the future. So let's get into it. So the first thing I want to talk about before we get into those patching standards is the concept of subpatchers and abstractions and just define what each of these words means. So all a subpatcher is a patch inside another patch. So I could make one by creating a patcher object. And now I have a subpatcher. And I can also just use P and it will give me the same thing. So this is a patch inside of another patch. If I choose to save that patch, so this is a saved patch with a file name, then that is what we call an abstraction. And abstractions can be subpatchers. So this is an abstraction, which is saved. And I actually talked about this patch in a separate video. It is saved, and then I can use it inside of this patch as a subpatcher. So that's what those words mean. I often mix them up. You've heard me, I'm sure, many times in these videos say subpatcher when I meant abstraction or abstraction when I meant subpatcher, but that's kind of the precise definition of these terms. The reason that this really matters is the moment at which you ever find yourself wanting to use a subpatcher more than one time, and that includes more than one time within a given patch, or if you want to be able to reuse it in other patches in the future, that's the point at which you want to save it and convert it into an abstraction. And it's also the point at which I think some of these best practices become even more valuable. I think that they're valuable regardless, but they're really, really valuable when you have abstractions because now you have this thing that's going to have potentially a life beyond this specific patch. So giving it a little bit of infrastructure that allows it to function in a general purpose way is very valuable. So that's the distinction between those two things. Let's now get into the patching itself. So we're going to use this one as an example. And I'll just talk through kind of how this one is constructed just from the perspective of being a patch, not the function of the patch itself. If you want to know about that, you can watch the other video. I'll put the link down below. Okay, so the basic idea here is that we are interested in sort of making our patch work like it's a Max object. Because the Max objects are very well designed, there's a lot of care and design work that goes into creating those, and there's a sort of logic by which they operate. And one of the most important things is that we have this concept of attributes of an object and messages to an object. So every Max object has attributes, which are its properties or its parameters that we can set the values of. It also has messages, which you can think of as like functions. They're commands that we can send to the object in order to tell it what to do. And with any Max object, we can send messages to the object that allow us to trigger those messages, trigger those functions, or set those attributes. We can also use arguments in the patch's object box in order to set those attributes. So let's take an example just with a Max object. Going back to the main patcher here, if we use, I don't know, let's say live.scope. Actually, not live.scope because it's a UI object. Let's do subdiv. So subdiv, we have the first argument is going to be the subdivision, which we can set this way. We can also set it by specifying specifically the attribute that relates to the amount that this subdiv will subdivide, and we can set its div that way. We can also send that as a message into the object later and override this default, right? Of course, if I send a signal into this subdiv, I can send it into that same first inlet, and it knows what to do with that signal. So what I kind of want to do with my patches is have them work a little bit like this. I want to have, as much as is reasonable, one inlet. I want that inlet to be able to receive basically all of the things that need to be able to go into this patch. And I want to be able to address my quote unquote attributes, although attributes is not really a concept in subpatchers, but we can sort of think of them as having them. And messages, I want to be able to address those with messages to the object. And I also want to be able to handle different data types that object is likely to receive, like a signal. Okay, so the basic idea is we have a single inlet, and then we can use one of three objects or a combination of those three objects to be able to basically do some routing of the inputs that the subpatcher receives. And those objects are typeroute, route, and routepass. And these all do the same basic thing, which is that they take whatever comes into their first inlet and they route that data to one of their outlets according to some condition. In the case of typeroute, it's the type of the incoming data, which can be a signal, a bang, an int, a float, a symbol, which is just a single symbol, or a list, which is a combination of many bangs, floats, symbols. And I guess bangs can't be included in lit. I think they can. And also matrices, like if you have a jitter matrix or even a texture would come through the list output, because a matrix is just actually, as far as the kind of max patch is concerned, or as far as max objects is concerned, is just a list. So this is the first one, and this is used in situations where we want to be able to segregate signals from messages, basically. That's really the way that I use it. In those situations where I have a signal processing object, and I have some commands that I want to be able to send to it, some attributes I want to be able to set, or messages I want to be able to trigger, but then also that object can receive audio. So that's where typeroute gets used. If I were going to make sort of a clone of subdiv, let's try it. So p subdiv, and I'll set up an inlet and an outlet. And then I have a phaser, 0.5. And live.scope. Okay. So we'll use the typeroute here because we know that this object is going to receive a signal. If I then just pass that straight through to the outlet to start, then I can see that. And then I'm going to have some functionality in here. So I'm just going to do a basic subdivider here. So we'll multiply this signal, and then we'll take the modulus. So right now that performs no transformation. But then if I want to be able to change this subdivision, then I could have a quote unquote attribute. It's not really a concept in a subpatcher, but we can think of it as having one, and it's helpful. We can then, from the rightmost outlet here, which is the list outlet, we can add a route object, and we can have that checked for the message div. So now if I send div4, or let's add a $sign here, and then I can patch it like so, then I can change this subdivision that way. And I don't need a separate inlet for this. One of the big reasons for using this approach, in my opinion, is that we cut down on the number of inlets that the patch has. Because everybody's had projects where they have subpatchers that have like 15 inlets, and it's really, really hard to keep track of what data is going in where. You have these kind of streams that flow from subpatcher to subpatcher, going from the 4th inlet to the 5th outlet to the 3rd inlet of the next subpatcher, and it's just confusing. It's really hard to follow what's going on. And if you need to refactor the patch in any way, like you need to be able to rearrange things, then that can get really messy and difficult because you're having to manage all of these complex patching scenarios and make sure that you don't break any functionality that you don't want to break. So by minimizing just the number of patch cord connections that we need to have, I think we end up with patches that are easier to follow and easier to maintain. So that's one of the major benefits. The other one is that this is self-documenting, right? So rather than having a second inlet here where I take in the div and then needing a comment to be like, oh, this is the div parameter, I can just see very clearly exactly what this does. Similarly, inside the subpatcher, I can see very clearly what's happening here. We have a supported message that's called div, and it does subdivision. It scales that signal. What we can then do in addition on top of this is support the ability to set this div attribute using arguments in the subpatcher object box. So I'm going to create a patcherargs object. And what this object does is gets the contents of the object box. So if I hit a bang here, you can see that it's telling us the first argument, which in this case is subdiv, because this is a subpatcher. The name of the object, like the object's type, is patcher, and so then the first argument is subdiv. If then I were also to add on top @div here, @div 8, and then I bang this again, we have to print it. You can see that it will look for any that have an @ symbol at the beginning, and it will send them from the rightmost outlet. So this is the way that I have it set up usually. I don't really worry about this left outlet, which is going to output basically all of the arguments that precede the first one that has the @ symbol. And then once it sees an @ symbol, then it starts to use those @ symbols, and it will output each one of those arguments separately. And then finally, it will give us this done message. So just as an example here, if I said, @fo fi phi, it will give me div 8, then it will give me foo fi phi as separate messages, and then it will give me done at the end. So we'll clear the console, and there we go. So what this means is that I can save this subdiv abstraction, and then I can be able to use it and set default attribute values with patcher arguments. And there's a really elegant, elegant patching here, which is just that I send the patcher args into the same inlet that the patches inlet receives messages from. I could also put it here because we know that those are always going to be messages. And I'll also add a route done so that we can just get rid of that last message and force that to be ignored. So the done would come out here. We're going to ignore that. And then anything else will come through and go into this route div. So now basically the same mechanism that we're using to support the messages that we send into the patcher from outside are also supporting the patcher arguments. So now if I grab this, let's set this to 2, but then if I copy this and create another live scope and then patch the phaser in, you can see that we have a subdivision of 8 off the bat. So again, this is a self-documenting patch. We are able to initialize this abstraction for this specific patch in a way that's really, really clear and really easy to follow. You can also use the patcher args to create a kind of global initial state that would apply to your to your abstraction anytime it is used, and the attribute value is not already set. So if I were to say, hey, well, I want the subdivision of this subdiv patch to be 16 by default, then I can do this. And then if I were to get rid of this, let's say, let me make sure I did this in the correct one, because now I'm working with multiple here. Okay, so it's this one. Let's get rid of this one. So I'm going to delete this. I'm going to copy, and then I'm going to patch this together again. And you can see now we have a subdivision of 16 because that's the default. If I wanted to override this, of course I can, and I can do that either with a message, div 10, or I could do it with the patcher arguments. So if I copy this again, and I say at div 32, then I believe that was 30. Was that 32? Div 16. Why did we get div 16? Interesting. So yeah, this is weird. It seems that there's something having to do with, I wonder what would happen if I save this. So let's save this to, so let's try now, subdiv abstraction at div 32, live.scope. There we go. So it seems like maybe this patcherarg stuff doesn't behave quite the way that you would expect it when you have a subpatcher that is not an abstraction, but if you save it as an abstraction, then you really get it working the way that you want to. And this kind of construction here is basically, with this approach, going to be at the top of every patch that you make, because this is just general plumbing that every patch has. And this is really like the heart of it. I think if you were to kind of stop this video here and just start doing this, you'd be like totally set. But let's go look at this JIT LFO and talk a little bit more about some of the other ways in which this stuff has been used. So here we have, this one doesn't take a signal, so we don't need to worry about typeroute. And route is nice because it can look for either messages, but it can also look for types as well. So if I wanted to be able to basically, in this case, like I want bangs to always come through this first inlet, and then I have a bunch of like quote unquote attributes that come through the rest of these inlets. And then I also have another section of the patch, because there's kind of two sections of the patch. Like there's this one where we actually generate this LFO with this gen patch. And then we have this section here where we're basically calculating some numbers that need to, well, one number really that needs to flow into the gen patch. And so those are kind of two zones of the patch. And so I've separated them visually. And then I've also set it up so that the messages that go into this section of the patch just flow from the rightmost outlet of our route object and just flow down here into the section where we need them. And then it's here that we actually address them. You can see here that I'm using routepass in this particular case because this is a gen patch that has attributes, parameters rather, that are FM ratio and FM depth. And so I want to preserve those prefixes. So I use routepass in that particular case because route and routepass are basically the same. If I use route foo and I use routepass foo. Oops. And then I say foo 57 here. And then I add messages boxes. They do the same thing in terms of routing the message, but the way in which they differ is that the route pass will preserve that first item. So sometimes you want that, sometimes you don't. In these kinds of cases where I know that the patch that's going to be receiving that message actually cares about that prefix, I will use route pass. And in fact, there are many situations where I would have, let's take this one as an example. So this whole section is basically computing a frequency, but it takes three inputs. It takes the frequency, the coarse, and the fine, right? So we could take all of this and just collapse this down, and we have three inlets. But very often what I'll do in this case, and this may just be me being a little bit crazy, but I think it works pretty well, is I will do the same treatment to this subpatcher. So I will say route course fine, or what was it? Freak course fine. Freak course fine in that order. And then I will replace these connections. This goes away. And already to me, this is better because rather than me having to remember what these do or label them, the labeling is just part of the patch. Like it's very clear what this does. And then this is where I would maybe swap in a routepass. So routepass freak course fine. And we'll get rid of all of this. We'll send this here. And we'll also send it here. So this particular route is reserved just for these two messages. And everything else that it doesn't know about it just passes on. And then you have some options. You could either just pass this straight in, right? Because we'll be checking for freak course and fine. If you want to be really pedantic about it, which I sometimes like to be, you can even do this. I also wish there was an object that would let us specify a list of items and then just have like it filter. So there's only one outlet. I think that would be super handy. I have a abstraction of my own that does that, but if it were a max object, I think it'd be really nice because then you wouldn't have to do something like this. Again, right, like this isn't functionally necessary, but I think from a sort of patch hygiene perspective, if you were going to, have to look at this patch later and figure out what was going on with it, this would be really handy because you'd be able to see super clearly, oh, okay, freak course and fine. And then of course you want to name this. So we could say, calculate frequency. And you can kind of stack the routes and route passes in any way that makes sense to you. An alternative that you can use instead of using this final outlet of the route would be to just connect this like this. And so then we kind of have these three separate sections for the messages for the routing. And in this particular case, there's a kind of general rule in Max, which is like, you should always use, what's the word? Trigger when you have multiple patch cords going into the same inlet. In this case, we don't really care about that because any message that comes through here is only going to actually get taken up by one of these route or route passes. The one thing that we need to modify here is we need to make sure that the patcherargs goes into all of these. We could do this, but instead I'm just going to add a zlreg here in the middle, which is just going to act as a pass-through. You could also just use an empty subpatcher if you wanted. So that's another way to achieve the same thing. I tend to use the approach where you just have like a route at the top, and then you just kind of like pass whatever it doesn't recognize to its rightmost outlet, because that's also one of the features of route, that if for any message that it sees that isn't specified in the object's arguments, it will just send it to the right outlet. So I kind of just daisy chain those, but this is totally valid as well. Another thing that you can do in these types of situations is, like, say you had a really kind of more complicated patch and you wanted to be able to sort of route like hierarchically, then you could say, okay, I have, rather than using like FM underscore ratio and FM depth here, I could actually say like ratio and depth here, which would require that I change the parameters of my underlying gen patch, but we'll pretend like that wasn't the case. And then I can have like a route FM here. So then I could have messages that come in that are like FM ratio, 45. Well, that doesn't make a lot of sense. 2.5. And then that would flow this way. And of course that would apply to this whole section. So you'd have to say FM depth, FM low, FM high. this is not something I typically do, but this can be, can be handy in situations where you have like pretty complicated routing requirements and you want to be able to keep things really well organized. It works a little bit like OSC in that sense, where OSC is this kind of path-based hierarchical style of handling messages. It works very much in that fashion. And this kind of approach can be useful in lieu of using tons of send and receives, right? So you can sort of start to move to an approach where you say, okay, I have like a limited number of sends and receives if I need to send data or send messages a long way across my patch, maybe from my UI to kind of the main engine of my patch, rather than having specific sends and receives that are allocated for like specific purposes, like filter cutoff as a send and receive. Instead, you just have one send and receive that's like, to engine, or from UI. And then you can just listen to that receive everywhere else in the patch. And then the messages that you send over that channel would be like filter cutoff or whatever the thing that you're controlling is. And then you can use this exact same solution to be able to handle those. So you have, instead of kind of these individual pathways for specific kernels of information and a proliferation of tons and sends and receives, you have one send and receive that's kind of a global broadcast, basically. And then each object or each patcher handles that information however it needs to. In some ways, you might say that particular approach is less good because you have to do a lot more patching kind of at the end of the communication chain. But I think for the reasons that we've explored here, it actually is better because it just means that every patch has a very clear definition of what its API is, basically. We're very, very clear about what can go into this patch and what happens when that message goes into that particular patch. And again, I said it at the top of the video, but I think when you think about the need in the future to reuse a given patch, and you want to be able to just drop that in and use it, being able to open up the patch and see inside what the messages it will take are in the very top object is just really, really nice. So I think that's a huge benefit. So one other thing I want to talk about is, are there situations in which you would ever want to use multiple inlets? Like, am I an inlet absolutist where I'm like, no, you should only ever use one inlet? Certainly not. There are situations in which multiple inlets can be really valuable. One is a situation where it's unavoidable, which is you have multiple signals that are going into the abstraction. So if we took an object like rate, like because this object can actually receive two signals, there's no way to get around needing two inlets. So that's a situation where multiple inlets is completely justified and is in fact necessary. And then there are also situations where I think having a separate inlet for messages can be valuable when the second inlet receives some data that is really core to the function of the patch, but it doesn't trigger output. And so an example in the object space where this always happens is the ZL family. So if we looked at ZL lookup as an example, we could re-engineer, like Cycling74 could re-engineer ZL lookup so that they got rid of this right inlet and made you put in like lookup list and then whatever your list is, 1, 2, 3, 4, 5, 6. And then any integers that you pass in there will look up items in the lookup list. But like, this is just what this, oh, I crashed Max. That's funny. Okay. Sorry. Yes. That's funny. Yeah, I think there's some problems with autocomplete. So when I'm real, like, kind of intense typing and I confuse the autocomplete, it tends to crash Max. But anyway, it has these separate inlets because that's just what ZL lookup does, right? Like, we know that that's just what that's for. And also, when I put in the message into the right inlet, it isn't triggering the output. So we would make this inlet is blue, it's cold, telling us that I'm just putting numbers in here or whatever, putting a list in here, it's not going to trigger the object to output anything. So in situations where you want to be able to do that, you can create that second inlet, and then you can show as cold here in the inspector, which makes it clear that that's a cold inlet. It's not going to trigger outlet. On top of that, you can also use the comments, which are a good idea. Or we could say, like, I don't know, like whatever it is. So, list to be looked up. Say we were using, we were making a clone of CL lookup. For that first one, I guess that's a little bit less important. You could put something generic there because it's really all of the messages kind of that the object supports. But for those additional inlets, those assistant comments, I think are pretty valuable. And the same goes for the outlets. So for the outlets, you can do exactly the same thing. You can add an assistance comment. And let's actually talk about the general concept of outlets. So to some extent, we can follow a similar scheme here, where for a lot of what we want the object to output, depending on what it does, we could just prefix those outputs with symbols that tell us what it's producing. So if we took an example of, I think a good example would be like dict. So if we take dict, and I'm just going to put some basic data in here. So we'll say, we'll put like the Tour de France winners. So, and 2025 was Tadej Pogacar. He's pretty dominant. Okay. So if I say get 2024, then from the second outlet, it will give me that response, and it does it now with this new max string thing, which I don't know, maybe is that actually helpful to us? I'm not so sure, but so we'll do like a ZL slice to get rid of the first thing, ZL slice 1, and then we'll do a string.toSymbol, and then we'll do this. There we go, Tadej Pogacar. So the point that I'm making here is it will initiate the list that it outputs with the thing that you asked for. And this object uses separate outlets for different purposes, which I think there's an argument for that. Like, this is only for the complete dictionary. This is for responses to the get message. This is for responses to get keys. But I think actually, if I were designing this object today, and I were king of cycling 74, I would, in place of having, let's say, a third outlet that's just for get keys, I would just initiate the list that comes out of the first outlet with get keys, so that on the outlet I could put route dictionary and get keys and any other key that I'm querying. So, 2024. This isn't going to work, obviously, but it would be like if I said get 2024, then it would send 2024 here, so that I don't have to like scrub over these, because that's one of the things I find the most annoying is like having to be like, okay, wait, which one was it? Like particularly like transport is a pain, as well as info tilde. Like I'm always like, okay, which one's the milliseconds? It's not this, it's this one. It's like fourth from the right. I would much rather just have one and just use a route to be able to separate those things from one another. A little bit like jit.matrix info. Every time this object receives the matrix, it tells us data about that matrix using these messages rather than having three outlets. I think there's an argument both ways, but just know that this is a strategy that is available to you, and you can make the decision about whether you want to use separate outlets and then have to kind of annotate those outlets, or whether you want to just use messages this way. And, I would lean towards the messages, and one of the main reasons for that is because this route object, while it is a little bit of extra bit of patching, documents your patch. So you can actually see from the outlet of this exactly what is flowing here, and when you look at the patch, it's a lot easier to understand what's going on. So that, I think, is something to think about. It's a design decision at the end of the day, so there's no right or wrong, but hopefully that gives you a little bit of a framework to think about outlets. And then, of course, the final rule always with outlets is you want to follow the right to left order that we have inside of Max. So you don't typically, really under any circumstances, want to have, like, if multiple outlets are going to produce an output at the same time or in response to the same event, you want to have the outlets on the right produce their output before the ones to the left. And if we look at the JIT LFO, one improvement that I could make to this patch, just to make it like really rock solid, would be to use a trigger here so that my two outlets are fixed in order, right? Now, this is actually kind of fine because we always know that the one that's furthest to the right will get its response first. And if I switch this around, then this one would become the first outlet and that order would actually be flipped. So actually, maybe this is actually maybe this is the one case where you should connect multiple patch cords to the same outlet of an object, because it will preserve the right to left order for the purposes of the output of your subpatcher. I just thought of that. Maybe this is the best practice here. But yeah, anyway, the point is, like, especially when you have more complex ones where you're going to have multiple things coming out of those outlets, if you're choosing to go with kind of a multi-outlet approach, you just want to make sure that that order is preserved, because again, when you come back to the patch later and you're trying to figure out what the heck's going on, or if you're going to use that later within another patch that has perhaps a little bit of a different program logic, like just having those basic rules of Max of right to left ordering be obeyed is going to remove variables from the equation that can confuse you and cause surprising results and just make Max patching less fun. So that's, I think, an important rule to try to follow. Okay, the only other thing that I won't go super deep into, but one of the other kind of cool features of this approach, particularly if you do it this way with this kind of like daisy chain thing. So at the end of your chain, then I can do like an error here that's like, sorry, this patch does not support the message $. And then if I send hi 46 or 45 into that one. Oh, wait. Oh, wait, I want print at level 2. So it's not an error object, it's print at level 2. Okay, let's try that again. But I used a comma. There we go. Sorry, this patch does not support the message. Hi, right? So that's nice too. If you really want to get super fancy with it, you can start to do stuff like that and like have your patch throw errors. So, okay, that's it for this one. Let me know if you have any other thoughts about this. I'd love to hear your disagreements. I'd also love to hear your tips. Like, what other strategies do you use to keep your patching clean and better and more fun and easier to reuse in the future? Is there anything that's a technique that you would add to this kind of general family of approaches? I don't think this is totally figured out, but I feel pretty good about this kind of set of techniques, and I've been using them pretty heavily for like several months now, and I'm pretty convinced. So, all right, thanks. See you next time.